Hello everyone, welcome to section 1.5, which in our Geometry Honors class is going to talk about special kinds of angles. So we just came from section 1.4 where we learned what angles are and what different types we have. But now when we start to pair them up, a lot of them have special names. So today we're going to learn all about the special types of pairs we have of angles, including one of my favorite types ever. Alright, so if you want to print out these notes first and then write on them, or you can just go ahead and write your own notes as you normally do. If I have two angles that add up to 90 degrees, if they add up, we call them complementary. Complementary angles are two angles, and only two, that when you add them up, you get 90 degrees. It's possible to have, say, three angles that add up to 90, but we don't call them complementary because they have to be only two. Only two angles. That's why this whole section is called special pairs of angles, not trios of angles. So over here you can also tell on the right hand side that this angle and this angle are also complementary because they add up to 90. Or as we learned before, they add up to a right angle. So in this picture I actually could draw that cool little box, right? Because that's now 90 degrees. Yay. Okay, now how do we say it in English? You can say over here on the left side that angle R and angle T, notice that we're calling them by their vertex, and that's totally legal. Angle R and angle T are complementary. That's one way of describing it. Or we can say that the angles are complements of each other as well. So in the right-hand side picture, we have angle XYW and WYZ are complementary, but then we can also say that each one is a complement of each other. They complement each other, which means they both add up to 90. Great. Okay, so besides adding up to 90, what if we took angles that maybe added up to 180? Remember 180, that's a straight angle, so it'd be a straight line. Okay, well, let's see. We got a special word for that. We call that supplementary. Supplementary are two angles, and only two angles, whose measures add up to 180. Or as you can see here, it could be like a straight line. In the left picture here, can you see that because angle A and angle C add up to a straight line, they are supplementary. And do you remember from the last section too, two angles that are back to back that add up to a straight line are also called a linear pair too. So these pair of angles on the left hand side are also called a linear pair of angles, if you had good memory for that. Okay, they add up to 180, which is a straight line. But if I write the angles separately, like on the right hand side, they can still be supplementary, because you can see here this angle is 40, this one's 140, and that adds up to 180. So these two angles are also supplementary. Okay, English, here we go. You can say that angle A and angle C are supplementary, just like we said they could be complementary. Or we can also say that the angles are supplements of each other. So angle X here, calling it by the vertex, and angle R here are supplements of each other because they are both supplementary. Okay, now you've got two different important words here. You've got complementary, you've got supplementary. You've got two numbers, 90 and 180. Here's a great way to think about it. Just think of the alphabet. C comes before S, complementary and supplementary. And in math, the number 90 comes before the number 180. So think of the furthest letter has the bigger number, or the earliest letter in the alphabet has the smaller number. But a great way to remember it is just this way. So complementary is 90 degrees, supplementary is 180. All right, we'll play with a lot of examples of these later, but first, can I give you a really good SAT type problem? Oh, SAT. Write this one down. I'm going to put a little star next to it because it's such an important one and such a tricky question. All right, here we go. I know that the supplement of an angle is 3 times as large as a complement of the angle. Can you find the measure of the angle? My first response is, what? What does that mean? So here's what we're going to do. Let's take math from the English. So everything that's in English, let's translate it into math. Ready? All right, the first part I'm going to take. Let me erase all these underlines so I can really see it. The first part I'm going to take, friends, is a supplement of an angle. Stop. Well, I don't know what the angle is, and we're going to try to find the measure of the angle. So if we don't know what the quantity is, remember what we do in typical word problems is we give it a variable. So why don't we just call the measure of the missing angle that we don't know, it's called x. So therefore, if we took this little bracket here, friends, and I said, what is the supplement of an angle? How would you express that in terms of x? I don't know. Okay, my brain is thinking over here. Here's my brain thoughts right now. I'm thinking, all right, if Mr. Brown gives me an angle of 40 degrees and he says, hey, give me the supplement. How could I find the supplement of 40 degrees? You think, well, they both add up to 180, right? So if that's 40, the other one must be 140. Oh, yeah, that's the supplement of 40, right? How did you do that? How did you figure out 140 from 40? What did your brain do? And I think what you did is you took the 40 and you subtracted it from 180. You said, you know, they both have to add to 180, so let's take the angle I gave you and subtract it from 180. Okay, cool. That's great. So what if the angle I gave you was x? Because I don't know what it is. What's the supplement of x? You would say, I would take the angle and subtract it from 180. All right, so that's first bracket translates to 180 minus x. Great, let's keep going. Okay, next big word here is. What is in math? When you take is, that just usually means equals. So something is means something is equal to. All right, next bracket here. How about we let's take this portion. 3 times as large, stop. When something is 3 times as large as something, it's 3 times as big, so it just 3 times it. Multiplication. So I'm going to open up a parentheses. I'm going to be multiplying something by 3 because it's 3 times as big. Okay, last part here. 3 times as large as a complement of the angle. Ooh, a complement of the angle. So if the angle is x, what would be the complement? Can you use the first part that we did? What's the supplement of the angle? How did we write that? Okay, how are we going to write the complement of the angle? Here you go. Do you see it? If the angle is x, then the complement of that angle would be 90 minus x. Great. Okay, look what you guys just did. You made a beautiful, beautiful equation with some algebra. All right. I'm going to give you a challenge. Can you pause the video right now and can you solve this for x all by yourself? Good luck with the algebra, and we'll come back and check. Okay, friends. So on the left-hand side, if I got rid of the brackets, I just have 180 minus x, and I'll take away the degree symbol for now so I can just work with pure numbers. On the right-hand side, I really should distribute that 3 in and do multiplication. So 3 times 90 is 270, minus 3 times x is 3x. All right, now we've got to gather all of our x terms together on one side, and all of our leftovers, our constants we say, on the other side. So I'm going to do that by adding 3x on both sides. And if you wanted to add x to both sides and put it on the right-hand side, that's fine too. Okay, that gives me 180 negative x plus 3x. That will give me a plus 2x equals 270, and the 3x and negative 3x goes bye-bye. Poof, gone. Okay, next step. The 2x is great sitting over on the left-hand side, so we should move this 180 over to the other side by subtracting it. Okay, so I'll subtract 180 from both sides. You can come up here, friends. The left side, I would just have 2x left over. And the right side, I would have 270 minus 180. And I think that would be, 90, I think. Okay, cool. All right. So now, last step is just divide both sides by 2. If I divide both sides by 2, to isolate the x all by itself, 2's are gone, poof, and I get x equals 90 divided by 2 is just 45. Okay, now, that means the missing angle that we're trying to find is 45. We're done, but it'd be really good to double check in case we made an algebra mistake. So we can just plug it back in and just use the words here from the entire problem and see if it really is true. Okay, if my angle is 45, what would the supplement of that angle be? What would 180 minus 45 be? I think that would be 135, right? Okay, so the first part says a supplement of an angle, okay, 135, is 3 times as large, 3 times as large as the complement of the angle of 45 degrees. So if the angle is 45 degrees, what's the complement? Well, they add to 90, right? Oh, it would just be another 45 degrees. 45 plus 45. Is this true, my friends? Is 3 times 45 give you 135? And guess what? It does. Hooray! So put a big star next to that kind of problem because I said it's likely to see on the SAT. We love seeing these kind of cool logical problems. We built an equation, translating the English into math, and then we just solved. Whew, good job. Now, it's going to take me back to the linear pair postulate, or the LPP, that we talked about in the last section. And if you remember, the linear pair postulate said if you have two angles that make a linear pair, then they add up to 180, right? Because they add up to a straight angle. But now we have a special word for that, right? These are two angles that add up to 180. What do you call a pair of angles that add up to 180? Ready for the big reveal? Dun, 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 dun. There you go. So if you want to rewrite this postulate and just now insert the word supplementary, we're just rewriting the same postulate but just using different words. Instead of saying, oh, they add to 180, well, we're grown up since then. They're actually now supplementary. And again, friends, flashcards are great for these postulates just to help you remember and help you memorize them. Okay, we're coming up on my favorite pair. My favorite pair of angles are called vertical angles. I love vertical angles. Maybe it's because the way they look, the way we draw them, but I think more it's because of this theorem that we're going to see on the bottom. It's my favorite theorem in this chapter. Vertical angles happens, folks, when you draw sort of an X shape, and it's the angles that are opposite of each other. These two are vertical angles. Or these two are vertical angles. Okay, officially though, if we're going to give it like a geometric definition, vertical angles are two angles, for example, we'll take the two red ones, where the rays, or the sides of one angle, are opposite rays of the sides of the other one. So the ray of this angle on the bottom is an opposite ray of the ray of this other angle. That's how we say it by definition, but really, the first way I said it, where I said they're basically opposite when we're across an X, is probably the easiest to remember. So if you look in this picture down here, friends, you can see that angle A and angle B are across from each other, across from a big X, and so they are vertical angles. The cool thing is, do you also notice that angle 1 and angle 2 are also vertical angles? Now, if you want to use the geometric definition, say, yes, because in angle 1, this side is an opposite ray of this side of angle 2's ray. And this side of angle 1 is an opposite ray of this side. Yes, okay, that's fine. You can do that, or you can just see that, hey, I drew an X, and these angles are opposites of each other. So those are vertical angles. So here you see angle A and B are vertical angles. Angle 1 and 2 are vertical angles as well. Okay, so you draw a straight X, two lines intersecting, and the opposite angles are verticals. Now, I don't know if you noticed, but if I actually try to just look at these in terms of their measures, let's look at angle A and angle B. And imagine as if I'm sort of playing with some scissors or two sticks, and as I move these out, or I move these up, what happens to the measures of A and B? Because right now, they actually look like they're about the same. Can you see that? So now if I raise one stick up or one line up, it'll make the A measure bigger because I'm going to widen it. But remember, by moving this side, you're actually at the same time moving this one this way. And so what's that going to do this one? It's also going to make that one bigger. So I feel like no matter what, folks, vertical angles are always going to be the same measure, or we can use the word congruent. And that leads to both one of my favorite theorems in this chapter and probably one of the shortest theorems ever. It's only 4 words. Ready? Write this one down. Theorem. Vertical angles are congruent. Check. All right. I think it's our first theorem too, is it? That's great. Normally for theorems, we'll try to prove it in class, but we haven't really learned what proofs are or how to prove things, so we'll save this one for later. But write this one down. This is your first big theorem of the year, folks. Vertical angles, no matter what, are always congruent. And it doesn't really matter how thin I make that X. This angle and this angle are congruent. Or the one on top and bottom. I'll use the little congruent symbols for angles. This one is congruent to that one. Neat. Neat, neat. All right, let's play. In this example here, I'm going to tell you right now that angle 4 is congruent to angle 5. Now, these you can tell are not vertical angles because they're not opposite of each other across an X. But there are verticals somewhere. Can we find them? Let's just make a list over here of VAs. How about some vertical angles? Which ones are vertical angles here? All right, well, let's see. If I take this line and maybe this line, can we see angles that are opposite of each other? So I see that maybe angle 4, can you see that angle 4 is a vertical angle with angle 7? Sure, sure. Now angle 6 is also a vertical angle, but with like angles 8 and 9 together. So I'm not going to count 6 for now because that's kind of complicated. Okay, that's cool. So how about we do maybe, what's another 2 lines I could use? I can do this line and this line. And that means maybe angle 5 and also angle 8 are vertical angles. The other 2 would be sort of the 4 and 9 plus the 7 and 6. But again, that's kind of hard to notate, so we're going to skip that. Okay, and which 2 lines did we not use yet? I think it was it this one and this one? Good. And in that sense, you can see that angle 6 and angle 9 are vertical angles. And, of course, the 4 and 5 with the 7 and 8. But again, tough to notate, so we're going to skip. Okay, well, that's kind of helpful. Now that we know where the vertical angles are, we know which ones are congruent. Let me go back and mark back picture. So we said that 4 is congruent to 5 from the beginning. Can we name 2 other angles that are congruent to angle 5? All right, so we already know that angle 5 is congruent to angle 4. Why? Because they're given. They gave it to us. But now you made a list up here of other vertical angles. That means they all have to be congruent. These 2 are congruent to each other, these 2, and these 2, right? Well, what other angle is 4 congruent to? 4 is also congruent to, up here, 7. So therefore, if 4 is congruent to 5 and 4 is congruent to 7, then can you see that 7 is congruent to 5? And we shouldn't assume, we learned that last time, but you can just see that 5 and 7 look like they're about the same size. But again, we're not going to assume. Dangerous. But then remember over here that 5 is also congruent to 8. So I can put that all these guys are congruent. Now, I know it only asks for 2 others, and we did it. We knew that 5 is congruent to 4, so we also said it's also congruent to 7 and also congruent to 8. So great. That means they're all congruent to each other. So if one of them is 20 degrees, all those are 20 degrees. And that's how vertical angles work. Aren't they nice? They're so useful because if they're ever opposite of an X diagram with 2 lines, then they're always congruent. That's going to help us a lot. There is section 1.5, folks. There is your vertical angles and your supplementary and complementary angles, friends. Good job. Again, flashcards would be great with all these vocabulary words and theorems and postulates. But other than that, you are great. Well done, everybody.